Hello everyone, in this video we are going to show the P chart. The P chart is for the fractional non-conforming. If we connect m preliminary samples from the process, so we connect one sample at a time, and in each sample we may have number of items n, so this is sample size, may vary from sample to sample. So it's customary for each of the samples in a given application to include the same number of items n. Now, here we are not going to look at X bar or R control chart. We are going to look at the fractional non-conforming, that is how many defectives in each sample. So DI denotes the number of defective units in the sample. So the proportion of the defective for the ith sample will be Pi hat equals to Di over Ni. So let me give you an example here. Suppose we connect a bunch of samples over time. So this is time. At T1, we can collect a group of samples. So X11, X12 to X1n. And we count the Di is the number of defective items. So over here we have D1, and we have how many in total? This is n. Let's see how many in total. And we have Ni samples in total. So this is N1. We have N1. So fractional non-conforming, the proportion of non-conforming will be D1 over N. And we can do this for I. This will be Xi1, Xi2 to Xini, and we have number of defective items, and this is the total sample, the sample size for the ith sample, and the Pi fraction non-conforming will be Di over Ni. Okay, so now we are going to monitor the fractional non-conforming. So the fractional non-conforming is Pi hat. We're monitoring it over time. So an estimate of the overall process fractional non-conforming is P bar. That means we're going to, if we have m samples, we add all the total defectives divided by the sample size for the first sample size for the second sample, and total items. This is the defective items, number of defective items in sample 1. And this is the total sample size, the size of sample 1. If all samples have n items, that means those are all n's. So this will be P bar will equals to P1 plus P2 plus Pm divided by n. So the estimated standard deviation for the process proportion defective is SP equals to P bar 1 minus P bar over Ni square root. The P control chart lines, so we have 7 lines. We have the most important 3 ones are center line. So this is the center line. This is upper control limit plus and lower control limit plus minus 3 standard deviation. Warning limit plus minus 2 standard deviation. And this is 1 standard deviation lines. So SP equals to P bar 1 minus P over N. Now let's have a look at an example, and we are going to do the fractional non-conforming control chart using Excel after we discuss this problem. So this is South of the Borders Inc. This is a company. This company is doing customer wallpapers and borders. So this is a logo. Okay. So South of Borders is a customer wallpapers and borders manufacturer. While their products vary in visual design, the manufacturing process for each of the products is similar Each day, a sample of 100 rows of wallpaper borders is sampled, and the number of defective rows in the sample is noted. So the number of defective rows in samples from 25 consecutive production days follows. So determine the all coordinates. So construct and interpret the P-chart. So let's first have a look at how to construct the P-chart. So this is day 1. We have 100. We take a sample. The sample size is 100, and this is out of 100 rows. We have 13 defective rows. And this is day 2, we have 4 defective rows, out of 100 rows. This is day 3, we have 7 defective rows out of 100. So every day we're taking 100 rows out to do the sampling and to check the defective rows. And this is the variation of defective rows over the production days, over time. Now, we can add total items together because 25 days, each day 100 rows, so it's 2,500, so total samples, total items. So total number of defective items, is we add this column, so this column together, we will be able to get total number of defective items, so this is 196. So P bar will equals to total number of defective items divided by total number of items sampled. So this is 0.0784, and SP will equals to P bar 1 minus P bar over N. So this is SP. So we got P bar, and plus minus 3 standard deviation will be our upper and lower control limit. Now let's have a look at the Excel example. So this is exactly the same data we got. And we got, you see, this is day 1, production day 1 to production day 25. So this is approximately 1 month, right? So we're checking the defective products over time, defective rows over time. So we take 100 rows in day 1, and we found 13 defective rows. So what is the fractional non-conforming? So this is 13 divided by 100. And this is 4 divided by 100. So we actually just use this defective rows, number of defective rows divided by number sampled in each day. We got the fractional non-conforming in each day. So total number of defectives is the summation of this column. Total number of items sampled, this is summation of this column. So it's 2,500 because we have 25 days. Each day, 100 rows. So P bar is actually the total number of items sampled, total number of defectives divided by total number of items sampled. And SP is, you see SP here is P bar, this P bar times 1 minus P bar divided by 100, then we take the square root. So lower control limit will be C3, okay, will be this center line P bar minus 3 standard deviation. Upper control limit will be this one plus 3 standard deviation. And this is plus minus 2 standard deviation. This is plus minus 1 standard deviation. So we got all the control limits. Here, the low control limit you see here is revised to be 0. Why? Because this is a fractional non-conforming. It could not be less than 0. So if we get a lower control limit that's less than 0, we just replace it with 0 in this case. So what we are doing, we are trying to, you see here, just plot this. So this will be our fractional non-conforming PI. And what we are going to do is we are going to add data. We're going to add first, let's try to add the center line. The center line will be this column. Okay, so this is our center line. And then we can add our upper control limit. Upper control limit is this column. So we can add our upper control limit. And then we can add our lower control limit. Lower control limit will be this column, or 0. So in this case, we got the upper control limit, center line, lower control limit plotted for the PI, fractional nonconforming. If any points out of the control limit is out of control, that's a signal for us to go back and check our manufacturing process. And following the same method, we can plot for the plus minus 2 standard deviation line, plus minus 1 standard deviation line. Okay? So this concludes this video tutorial on fractional non-conforming control chart, that is also called P control chart for the fractional non-conforming.